Okay, let's illustrate the Poisson random variable with the following example. Let's suppose a technical support center that receives on the average 30 calls per hour. We want to know what's the chance they'll get exactly 60 calls in 2 hours, the chance they'll get less than or equal to 60 calls in 2 hours, and the chance they'll get between 50 and 100 calls inclusive in 2 hours. So we'll use that Poisson disk function. So if they get 30 calls per hour, what's the average number of calls in 2 hours? Well, it'd be 30 times 2 or 60. All we need to know is the average. So the probability of 60 calls in 2 hours, we can do Poisson dot dist. Okay, now x is 60 because we want chance of 60 calls. The mean is 60, and remember we use 0 to get what's called the probability mass function, or a false. Okay, notice the chance of exactly 60 is the mass function. Okay, if we want less than or equal to 60, it's what's called, we haven't used the term, but it's really the cumulative mass function. So there we would get basically a 5% chance of exactly 60 calls in 2 hours. Now for less than or equal to 60 calls, all we have to do is change that 0 to a 1. The third problem will be a harder problem. Okay, so we want 60, the mean is 60, and we want basically, we can put a 1 or a true there. It doesn't matter. So we get there's a 53% chance there'll be 60 or fewer calls in 2 hours. Now the chance of between 50 and 100 calls, that's tricky, because the Poisson.dist only does the probability of less than or equal to something. So if I want the chance of between 50 and 100 calls inclusive, I've got to take the chance of less than or equal to 100 and subtract off the chance of less than or equal to 49. Because what does that leave me with? See, if I go 0, 1, 2, we'll not type everything here. I go 49, 50, 51, 52, 99, 100. What I want is basically everything between 50 and 100. So if I do Poisson dist 100, I get everything that's less than or equal to 100. And if I do Poisson dist 49, I take away 0 through 49. That leaves 50 through 100. Now if you took away less than or equal to 50, you would only get 51 through 100. People have trouble with that. But so I'm going to start out with the chance of less than or equal to 100. So I put 100 there, the mean is 60, and I could use a true, whatever. Okay, that's less than or equal to 60, minus the chance of less than or equal to 49, put a 49 there, the mean is 60, and again I put a true. So the first term is the chance of 0 through 100 calls, the second term is 0 through 49 calls, so the difference there should be 50 through 100 calls, which is 92%. That concludes our examples of Poisson probabilities. In the next video, we'll quickly tell you what the mean, variance, and standard deviation of the Poisson random variable are.